Hello everyone, welcome back to Let's Unbound. Yes, we are back with another video which is 1.4 polynomial functions and rates of change. So be ready with pen and paper and solve along with me. As usual, there will be a concept overview and then 3-tier problem solving. And yes, I got a bonus questions too, so we can solve it after the video. And do watch the video from the beginning till the end so that you won't miss out any concept. And if any doubts pop up in your mind or you got a different approach, you can just put it in the comment box. We would like to help you out, right? So let's start. Polynomial functions. So what is polynomial functions? And we know already rate of change, right? So, and also we did linear and quadratic rate of change. After quadratic, we have cubic, biquadratic. So the square will become cube, cube will become power 4, power 4, power 5. So that this family of functions is called polynomial functions, and we are going to connect this and with this rate of change. As usual, in our pre-calculus, we will explore the shape, how the graph behaves, and rate of change means what? How the output changes with respect to input. So now coming to polynomial function in general form, P of x is a(n) x power n, a(n minus 1, xn minus 1, x power n minus 1, and so on, a1x, a0. So this a(n minus 1, a(n minus 2, a1, a0, these are coefficients like real numbers, right? And x power n, and this n should be a non-negative integer. So you can't use x power minus 2. No, that is not a polynomial. Non-negative integer it should be. Right? And generally you should write the polynomial in decreasing order of powers. So x power 100 means you go like x power 99, 97, sorry, 98, 97 in such a way. And the final one will be a pure constant without any of your variable. Right? So this is the polynomial function in general form. Now, so we need to understand one thing. If any polynomial is given, you should be able to find these things. What is leading term? What is degree of a polynomial? What is leading coefficient? Leading term means which has the highest power. For example, if I put x power 100 plus 3, this is a polynomial, like 3x power 102. Okay, so look at which has the highest power. This term, x power 1 or 2. So that complete term is leading term. Okay, so in this case, the leading term is a and x power n together. And degree of a polynomial is your leading term has a power with its variable, right? That is degree of polynomial is n. And leading coefficient, yes, this is the leading coefficient. In your leading term, we have a number before it, that is an. So you should be able to identify this. This plays an important role in analyzing the structure of the graph, right? Leading term, degree, leading coefficient, right? Moving to next. Local extrema. Local extrema, what is this? We did maximum minimum, right? So that is called local extrema, or we will say relative extrema. Okay. So when local extrema for a polynomial, if a polynomial switches from increasing to decreasing, there will be a relative or local maximum. Increasing means a polynomial will always be a smooth curve. So increasing like this, then it goes decreasing. In this case, we got a peak point. So that is local maximum. Extrema means maximum, minimum together. We are using this phrase. And if a polynomial switches from decreasing to increasing, we got a local minimum. So that's it. So this is like a quadratic function, right? But a polynomial will be like this, will be like this. So many structures, many polynomial, many functions and structures we can make. So this is relative or local extrema. Whenever there is an increase to decrease or decrease to increase, right? Next is global extrema. Global extrema means, or we will say absolute extrema. So both terms, they mean the same thing. So the largest value of the function anywhere it's on its domain. Okay, so local extrema means the peak at one particular neighborhood we are taking, right? So, but global maximum means throughout the domain, which is the peak, which is the maximum. That is global maximum or absolute maximum. Minimum is throughout your domain, which is the lowest point. That is the smallest value. That is the global minimum or absolute minimum. So, right. So next one. These are some important facts while analyzing the structure of the polynomial function. We should understand 2 zeros. There's a hill or valley in between. So A polynomial is a smooth curve. If it crosses x-axis at 2 points, your polynomial goes like this. Sorry, your polynomial goes like this. If it crosses x-axis at 2 points, if you find this case, then at least to one extrema is guaranteed. One, or either it can be minimum or a local minimum or local maximum, at least to one is guaranteed. Okay, so we can guarantee at least one. We are not telling exactly one. Okay, at least one. So here you see two it crosses. So we got three local extremas. Correct, but at least one is guaranteed. Right. So this is a theorem based fact. We will learn that in deeper. Now you can just move this as a fact. Right. Next one. Even degree U-turn that never ends. Okay, so if your polynomial is an even degree, it will be U-turn kind of thing. So it will be something like this. Okay, no ups and down like this. Okay, so if it's open up, there is an absolute minimum. So even degree, you have to find opening up or opening down like this. If it opens up, then there will be an absolute minimum only. So we can't find absolute maximum there. If it's opened down, there is an absolute maximum. Right? Now, point of inflection, the curve changes its sign. Yeah, we already know point of inflection. Concave up to concave down or concave down to concave up. Right? So this point is point of inflection. So from here to here, it's facing down. From here, it starts facing up. So if this changes, if the bending changes, then there occurs point of inflection. Right? So this is the easy way of telling smiley to frown or frown to smiley. So that will be your point of inflection. Now, very important thing, we must know about this polynomials. We are classifying this into two things, odd degree and even degree. You can observe this. This is an even degree quadratic. Ax square, it will start with, so even degree. It will be either facing upwards or downwards. Okay, when it will face upwards, if your leading coefficient is positive, it will face upwards. That is 2x square, it faces upwards. If your leading coefficient is negative, it will just look down, right? Negative 2x square, it will look down. Then one more even degree polynomial you see. Even degree polynomials, either they were both upward arrows like this or looking both down. So this is one thing. So how the end behavior? So if it's odd, even degree, and if your leading coefficient is positive or negative. Positive means both the ends will go upwards. Okay, and yeah, some behavior will be there, but end behavior will be like this. Negative means both will look down. Now, what happens when my degree is odd? So this is 5-degree polynomial. You notice here, rightwards up, leftwards it's go down. So if it's odd degree and positive, negative, again, it depends upon leading coefficient. Positive means right side it will go up, left side it will go down. Negative means the vice versa. Left side it will go up, right side it will go down. That's the example given. Okay. So this is important. Pause the video and grasp the concept, then move on to next. Okay. Now we are moving to first question. Let f of x be a polynomial function with the given values. Are there any guaranteed extrema? If so, state interval where they must occur. Okay. We learned a fact, right? If it crosses x-axis, then an extrema is guaranteed. Correct? So let's try this. F of minus 2 is 0. So that means at minus 2, the graph crosses x-axis. F of 1 is 4, somewhere over here. F of 3 is 0. Yeah, so the graph has 2 zeros. Okay, so 0 to 1 is 4 means it should go like this and then it should come back to this. So there will be a peak point in between. Either like this, minus 2 to this. So somehow, if I want to go from 1 0 to another 0, I will attain a minimum. Either it can be a maximum or a minimum. So yes, at least one guaranteed here. So first one is yes. Second one, minus 4 is 7. Okay, let's go to 7. Randomly I'm picking. Minus 1 is 1 here. F of 2 is 7. Okay, so here in decreasing to increasing, yes, there will be a local minimum. Correct? So this is also yes. Okay, but this does not comes under the category two zeros. Okay, they are not zeros. Then no, we can't say like that. So increasing to decreasing, there will be an extrema. Correct? Sorry, decreasing to increasing, there will be a local minimum. So that fact I applied here. So next one, third one, f of 0 is 5. When x is 0, it is 5. Okay, let me erase everything. F of 0 is 5 and f of 2 is 6. Okay, 0, 2 and 4. 0 is 5. Okay, 2 is 6. 4 is 7. But in this interval, it never come down. Correct? It's just moving on and on. So here I will say no, there is no guaranteed extrema. Okay, because it's throughout increasing. No change. And also I can't find two zeros. Right? So no. This is the first example, the basic thing. Now, question 2. For each of the polynomial function, it's my rough word, sorry. Right, for each of the following polynomials, determine if there is an absolute minimum, absolute maximum, or neither. Okay, so here, absolute means throughout the graph, correct? And the polynomial graphs will never have any breaks at all. So, for this kind of question, you need to use the end behavior. So, how the graph looks like, you should be able to plot that. Just a sketch is needed. So first one, check the degree and check the leading coefficient. What is degree? How can I find the given factored form? Very simple. Add all the exponents of the factors. So degree is 1 plus 2 plus 2. Add all the exponents of the factors. Even x is a factor. Okay. So it's 5. So odd degree. Next one, what is the leading coefficient? Positive or negative? Minus 2. So it's negative. Right? So negative means right side it will go down, left side it will go up, and something will happen in between. Okay, so right. So here we go. Right side, left side it's up. So this is the end behavior. Absolute means throughout, if you analyze, uh, it's going to positive infinity on one side. It's going to negative infinity on the other side. That is what the arrow means. Right? So here we go. So we can say what is the absolute maximum for this? Positive infinity. We can't say that. Now, absolute minimum? No. So no absolute minimum we can say. So throughout the global, the minimum is going to negative infinity. We can't define that number. The maximum is going to positive infinity. We can't define it. So here, no absolute, like neither you can answer. No absolute max, no absolute minimum. Right? Yeah. So now let's do B problem. G of x is x square x minus 3. Again, you need degree and leading coefficient. Degree is add up the factors, exponents of the factors, 2 plus 2 plus 2, which is 6, even degree. And leading coefficient. I'm writing LC, which is positive. You can't say anything, so it's 1 actually. So it will be both facing upwards. And some happenings will be there in between. But yeah, absolute maximums, we are just checking the end behavior. So absolute maximum, yes, both sides it's go to positive infinity, you can't define it, right? So no, because it's going on and on, you can't tell the number. Absolute minimum. That depends on where the peak, so where is the lower point, and we need to test with the values. So we can say, yes, there will be. But as of now, as of our beginner concept, we won't find that here. Okay, but yes, there is an absolute minimum somewhere in between. Right, so that's question 2. And next, we are moving to question number 3. So that's the question number 2. And here we are moving to question 3. Find the extrema of this. So here a graph is given. Extrema means you just do all the 4 extremas, like, local minimum, local maximum, global minimum, global maximum. So let's start with global or absolute, okay? So absolute maximum throughout the interval, which is the highest. Throughout the interval, the highest is this. This is the peak of the graph, right? You observe throughout the interval. So absolute maximum at x is equal to 0, right? Now coming to absolute minimum. Throughout the graph, which is the minimum point means, it's going on and on this side. So, okay, don't pick this. This is end point, but this still goes. You can just extend to minus infinity. So, absolute minimum is no, we are telling, because it's going to minus infinity. Then local maximum or relative maximum, you can see, and local minimum. Right? Local maximum is where you see increasing to decreasing behavior. Okay, so I can see it here. That is your local maximum. So yeah, this is at x is equal to 0. Now local minimum is where you find decreasing to increasing behavior in the graph. Increasing, increasing, decreasing. So only that. So local minimum is not here. So no. And you see one thing, absolute max and local max is same. And no absolute minimum, no local minimum. Okay. And here we go for, yeah, that's it. We complete 3 questions for today. Next is bonus question for you. Again, you can take a screenshot of this and solve this question. So type in your answer. I think your no decimals will be there. So type your answers in the comment box. So all the 4 extremas, absolute. So you can type in this way: absolute max, absolute min, local max, local min, and your number. Right? And make sure if this content helped you and if you like the video, you can share it with your friends, and also make sure to comment your doubts and queries. We will like to help you out here. If you want to join the student community of Let's Unbound, here a WhatsApp QR code. You can scan this and join. Thanks again, and we will be meeting in next video, that is for 1.5 very soon. Until then, keep learning, keep practicing, stay tuned, and save the playlist for future reference.